Hey everyone, today I'm super excited to share with you all my brand new Udemy course, Building a Real-Time Chat App with React, NestJS, and GraphQL. So this is a course that a lot of you have been asking for. It is going to be a complete full stack build, including the backend, which we're going to build in NestJS, and our UI, which is going to be built in React. We're going to build a real-time chatting application that's going to support messaging using WebSocket connections and GraphQL subscriptions. We're going to do a deep dive into many different topics in this course and really see how we can set up full stack development from beginning to end to make things really easy for us and build a production grade web application that is scalable. And we're even going to deploy the application on AWS. So by the end of building this application, you're going to be able to build and deploy your own production grade web apps. Now, I know a lot of people on this channel will really get a lot of value out of this course, so I'm going to leave a link in the description where you can get the course at the lowest possible price with a discount. I'm also going to go ahead and leave you with a large beginning section of the course so you can check it out and see if it's right for you. Thank you so much for all the support, and I hope to see you there. Okay, so we're ready to get started building our React UI. We're going to use Create React App as our tool for quickly setting up a new React application with TypeScript out of the box. We'll use Yarn as our package manager and run yarn create React app, and I'll call this chatter UI, and then provide the template option where we will select the TypeScript template in order to set up a TypeScript project. So we can see our project has successfully started up, and we can now cd into our chatter UI folder where our project will be running. And let's go ahead and open this up inside of our code editor. So I've opened up the UI in VS Code, and we can see the brand new project created with a package.json out of the box. We can see we have our React dependencies out of the box, as well as a script section, which can be used to actually bundle our JavaScript and serve it on an HTTP server so that we can actually locally develop our React application, as well as build it for a production build. You can also see we have our default public folder with a standard index.html. And importantly, in our source folder, this is where all of our boilerplate TypeScript code has been generated inside of an index.tsx. This is where we're initializing the React application and using the app component, which has this boilerplate HTML. So we can go back in our terminal and actually run yarn start, that start script from earlier, which is using React scripts under the hood to start up a development server on port 3000. So you can see that our development server is now listening on HTTP localhost 3000, and we'll go ahead and open this up. So now in localhost 3000 in my browser, I've navigated to this website, and we can see the boilerplate Create React App template here with our animating React logo. So now that we have React set up, let's get React Material UI set up, which is going to be the component and theme library we'll be using to easily build a good looking UI with very minimal effort in this project. All right, so setting Material UI is going to be pretty straightforward. We're just going to need to install some additional dependencies. So let's go ahead and yarn add at MUI/material emotion/react emotion/styled. Emotion is the default styling engine for Material UI. We also want to use the default Roboto font out of the box, so we'll want to make sure we install font source/Roboto. And finally, we want to get access to the icon library so that we can use some nice looking icons in this project. So let's add MUI/icons material as our last dependency. So with all these newly added dependencies installed, we can go ahead and rerun yarn start to start our server back up. Okay, so now let's go ahead and clean up our starting project a bit. Firstly, I'll get rid of this boilerplate logo that we do not need to use. We'll keep the index.tsx the way it is for now. However, let's go ahead and remove this index.css import. We'll go ahead and remove the index.css file. Then we'll go ahead and remove all of this boilerplate from our app component, remove the imports. So I've also converted the app to an arrow function just because I prefer that look a little bit better. Then we can remove the app.test file as well as the app.css, as we're not going to be using these. So now on our localhost server, we have no issues in our build. And of course, we just see this big ugly white screen now because we removed all this boilerplate and styling. Let's next go ahead and add a dark mode theme to our application so that we have a nice look out of the box, because dark mode is the best. All right, so I want to enable dark mode by default. Firstly, in app.tsx, we'll create a new const called dark theme and set it equal to create theme, import from MUI/material, and we will pass in an options object where we can specify the palette, which is essentially just an object listing the different color styles we want to use for this theme. And we can swap themes out at a global level in the app here to make this really dynamic. So I'll set the mode to dark, and you can see the other mode here, light. We want the dark mode. Now in our app, we're going to return a theme provider from MUI/material, and this is where we provide the theme, in this case the dark theme we've just set up. So you can see this prop here is going to be dynamic, which can be changed at runtime. We'll also set up a CSS baseline here, which is going to be some default styling. We're going to add an h1 tag where we'll just say dark mode to get the look and feel of some text in our application under this theme provider, which is using the dark theme. So back in the browser now, if we refresh to get a new root node, we can see that we now have this dark mode with a black background and white text. So looking at how our text is aligned in our document right now, it's not so great. It's really smushed to the end of the beginning of the screen here. So we want to provide some global spacing to all of our children components so that everything is uniformly centered and has some good spacing to it. And Material UI offers a component just for this. That's going to be the container component. So we can import container, and everything is going to go inside of this container. So right now it's just this one text node we have. And now if we go back to our application, we can see we now have this nicely kind of centered text with a bit of spacing around on the top, as well as some spacing on the left here. So now it's not pressed against the screen, it's starting to look much nicer. All right, so the first component we're going to start building is our login or authentication form. We're going to need a way to capture user credentials so that they can sign up or log into their account and authenticate with our application. So let's go ahead and get started with this. So in the source directory, I'm going to create a new folder called components. This is where all of our components are going to live. And I'll create a new folder called auth, where we'll create our first auth.tsx component. So I'll have a new const called auth, and this will just be an arrow function where we will return our JSX expression. And here we're going to use a Material UI layout component. It's the vertical layout component that they call a stack. So all this is going to allow us to do is to just wrap our child components and align them in a stack so they're vertically aligned with some spacing. So the way this works is that each component inside of the stack is going to get a new row in the stack. So we'll see how this looks when we implement our first text field. So we're going to use this text field from Material UI/material, and then we need to give this some information. So firstly, we're going to specify that the type will be an email because we're going to grab the user's email, and then I'll give it a label of email. Let's go ahead and add another text field in our stack, and this one is going to be the password field. So we'll give it a type of password and a label of password. And then finally, we'll include a button. And within this button component, this is where we specify the text that's going to live inside the button. So for now, I'll just say login. Let's go back to our app.tsx. Now specify the auth component. And of course, make sure we export default auth to export this component. And then we can import it in our app.tsx. And if we go back to the app now, we can see we have our login form starting to get built here. It is a little ugly looking, so let's go ahead and fix this up. So back in our auth component, let's go ahead and add some spacing to our stack here. So if we have the spacing and specify 3, we then see we get a little bit of spacing now in between our components in the stack. All right, so let's add some additional styling to our form to both center it and make it look a little bit nicer. Let's take advantage of the SX prop, which allows us to define additional CSS styles on Material UI components. So firstly, I want to set a fixed height on this stack. I'm going to apply a height of 100 view heights and make sure this is in a string. And then to set a width, I'm going to set a max width of 50%. And now to center it, we'll set a margin of 0 auto. And finally, we'll set justify content to center. So now we can see our form is nicely centered on the screen. So I want to make this form a little bit more narrow because it looks a little strange. So let's give it a max width of 30%. Now the form looks great. However, now if we minimize the screen a bit, we can see when we're at our smallest, like on a mobile browser, we can see the form is a little bit too squished. So we can actually apply responsive styling with Material UI. We'll set our max width equal to an object where we can now specify the different breakpoints we want to apply this style to. So I'll say on an extra small screen, I only want a max width of 70%. Then medium, we'll go back to our 30%. Now we can see we still have our nice narrow form once we're in large mode. And as we come down to a smaller screen, we can see the form starts to look better now. So let's continue adding improvements to our form right now. I'm going to change the variant to our text field to be an outlined. So by default, you can see the different variants we have for text fields. We have filled, outline, and standard. I like outlined the best, so I'll use that one. We'll do the same for the password field, setting it to outlined. And then finally for our button, this has another set of variants that you can see here, contained, outlined, and text. We're going to use the contained button. Now you can see we have this great looking form to accept an email, password, and we are ready to try to log into our app. So let's wire this form up so we're actually able to capture the user's credentials and do something with them. So to do this, we're going to maintain state in our auth component by using the use state in React. So we will set a new array here and get the email and set email variables that we will set equal to use state from React. And by default, this will be the empty string. And we'll do the same to collect the password. We'll have password and set password equal to use state with just open parentheses for the empty string. Now in our email text field, let's set the value equal to email. And then we'll have the onChange listener where we get the event. We're going to go ahead and call set email. And then we pass in the event.target.value to pass in the email. We'll go ahead and apply the same for the password. We'll set this equal to password, and the onChange listener will get the event. We'll call set password and pass in the event.target.value. So now in our component, we are capturing the email and the password in our use state, and we can now do something with these credentials. Let's go ahead and set up routing for our application next so that we can actually navigate between this login page and a sign up page and make sure we pass the appropriate props when we are on each page so that we can extend this auth component and get it ready to send these credentials to our backend server. So we're going to use React Router as our navigation solution for this React app, which is the most popular navigation library. So in order to set up React Router, we'll go ahead and yarn add React Router DOM, add local, forage, match, sorter, and sort by, which are all packages that React Router will be using underneath the hood. Then we can go ahead and start up our server once again. So in our index.tsx, we need to provide a router to our root of the application so that the routes will correctly be processed in our app. So to do this, we can create a new component in our components directory, and I'll call this directly routes.tsx. And inside of here, we're going to have a new const called router and set it equal to create browser router. And this function takes an array, and this array, every element in here is going to be a new object, which is going to represent a new route in our app. So we'll provide a path and specify that /login should lead to an element, and this element is going to be our auth component. So let's go ahead and export the default router from this component. And now in our index.tsx, we'll still keep our root app component here, but instead of providing the auth component directly now, instead of our container, this is where we're going to provide the router provider component and specify the router, and we'll now provide the router that we added just now. So now if we go back to our browser, we can see we have a 404 being thrown because we haven't defined a root URL. We will do this eventually, but now if we go to /login on localhost 3000, we can see we have our authentication component displayed, which is great. So now we have routing. So now I want to add a new sign up component, which is essentially going to be a pretty much copy of our login component. Instead of having login, we'll have a sign up button. But other than that, everything's going to be the same. And of course, our onSubmit functionality will be different. So in order to cater for these differences, let's create dedicated login and sign up components in our auth folder. So I'll create a login.tsx, and we can export this login component where we will simply return a new auth component for now and export default login. And I'll create a new signup.tsx, which will be pretty much the same thing. We'll change the name to signup. And again, this is just going to re-export the auth component for now. And now in routes, let's add the login component as the component for /login. And then we'll add a new path, so a new object where we specify /signup is going to be associated with the sign up component. So now let's go into the auth component and let's refactor this a bit. So now that we want to accept some new props in this auth component to conditionally render the login text and the onSubmit functionality. So let's define a new interface called auth props, and we're going to have a new prop called submit label of type string. And then we're going to specify the onSubmit function that's going to get supplied to this component, which is going to take the user's credentials, which will be of email of type string and password of type string. Then this is going to return a promise of type void. Next, we'll go ahead and actually use these properties in the auth component. We'll get access to the prop object where we can destructure the submit label and the onSubmit function and set this type equal to the auth prop. And now in the button, instead of displaying login directly, we will render the submit label, which will be a prop. And then we're going to define an onClick listener for the button where we will call the onSubmit function that's passed into this as a prop, where we will go ahead and supply the email and password from the state in our component. And make sure we change onSubmit here to fix that typo. So now we have a clean component that's taking the submit label and the onSubmit function. So now, of course, we're going to have to go back to our login component and provide these props to the auth component. So for our submit label in the login component, we will keep the submit label as login. And then for the onSubmit handler, for now, we're just going to keep this as an empty function and make sure this is asynchronous to keep the return types happy. We'll go ahead and do the same thing with the signup component, except now our submit label will be signup, and we will have the same empty asynchronous onSubmit handler for now. We can go back into the routes component and remove this unused import, and now we should see that our login components working as normal. And if we go to /sign up, we can see we now have the sign up button instead of login. All right, next I want to add a link so that we can actually navigate to the sign up form and go from the sign up form to the login form. So let's implement this by first going into the auth component, and let's accept a new children prop. And this children prop will be the underlying children that our parent component is passing in. So we can set this type equal to react.reactNode. We'll then go ahead and destructure the prop, the children prop. And then below the button, I want to add the children and actually render the children component inside of our stack. So now back to the login component, we can see it's complaining now because we don't have children being passed in. Let's go ahead and fix that now. Now we're going to go ahead and add this link from React Router DOM, specify the to prop where we will navigate to the sign up page. And then inside of this link, we can provide the text. In this case, it'll just be sign up. Let's go ahead and do the same thing in the sign up component. So I'll return the auth component with a children prop now, which is just going to be that link from React Router DOM. This time we're going to go to the login component and we will say login. Importantly, we have to add a leading slash to both of our links to make sure that this routing is done from the root of the application. So now if we go back to our login form, we can see we have the sign up link. It looks a little ugly right now, but importantly, we can show that we can click between the pages and we are correctly navigating. Let's go ahead and fix this styling. To fix this, let's fix this first in the sign up component. We want to actually import another link as MUI link from MUI/material. And now we have this MUI link. We're going to go ahead and use it inside of the React Router DOM link. So we will just have the MUI link and we will put the login text there. And now if we go back, we can see we have a much nicer looking login link that matches our theme. Now to actually center the link here, we'll give it a style and make sure we set align self to center. Now we can see we have this nicely centered login link. Let's do the same for the sign up. So we'll copy our import for the MUI link and paste it in, and then make sure we use it here. So we surround the sign up text with the MUI link and say sign up. And we'll also apply that same styling of align self center. Now we can see we have a fully functioning login form. So we're going to use the Nest CLI heavily in this project, and we're going to start off by using it to generate our application. If you don't have the Nest CLI, you can run npm install -g for global js/CLI at latest to get the latest version. If you run into permission errors, you might need to run the command with sudo in front and enter your password. With the Nest CLI installed, we are going to use it by calling nest new, and I'll call it chatter backend to generate our new backend project with NestJS. And I'm going to use pnpm as my package manager. So we can cd into our new backend folder and run pnpm run start dev in order to start up the development server, which will open up a port on localhost 3000 for HTTP requests on our one get route. Now in Backend VS Code, I want to add the backend to our existing UI folder so we can make this a shared workspace. In VS Code, I can do this by right-clicking and adding a folder to workspace. I'm then going to go ahead and add the backend to this workspace. And then lastly, I want to save this workspace. So we can go to File, Save Workspace As, and I'll call this the chatter.code workspace and save it in a directory that is convenient for me. In this case, it's just going to be adjacent to the backend and UI folders. So we have our backend, and like I said before, we have our main.ts, which is listening for incoming HTTP traffic on port 3000 as we bootstrap our app. We have our app controller with the one get route, which will simply return a hello world string. We can verify that everything's working correctly by opening up Postman and submitting a HTTP request on localhost 3000 for get. Send this request and we get our hello world response back. Okay, so the first step in allowing us to be able to save and create new users is going to be adding a database layer to our application. We're going to use MongoDB in this project as our database of choice. So to get started, we'll head to the command line and set up some new dependencies. So let's pnpm install firstly nestjs/config, which we're going to use to expose environment variables and read in things like the MongoDB connection string. Then we need to install nestjs/mongoose and mongoose, which is the ORM we're going to be using to connect to MongoDB. Lastly, to make sure that we can validate our environment variables, make sure we npm install joy as well, which is going to be a schema validation library we can use to validate our environment variables. So we're going to be connecting to MongoDB. In our case, we're going to run a local Mongo server to connect to. So if you don't already have Mongo installed on your machine, head to mongodb.com/docs manual installation. And here we can see a list of instructions for each operating system to install MongoDB Community Edition. Click on the link for your operating system, follow the instructions, and start up MongoDB. In my case, to start up Mongo, I'm going to run the mongod command and then specify my DB path is /db/data, which is just a directory where our collections will write data to. You can see the server has started up. Now we can connect to it in our NestJS app. Okay, so let's set up our config module firstly so that we can read in environment variables in a .m file. So to do this, we'll go to our app.module, and in the imports array, we will import config module from NestJS config and call for root on it. Here we'll specify an options object where we set is global to true, and this means that the config module will be globally available and we don't have to re-import it in the other modules when we want to use it. Next, we're going to specify a validation schema property where we can use joy to start validating our environment variables. So up top, I'm going to import star as joy from joy. And now we're going to call joy.object to specify this schema. We're going to provide our first environment variable, the MongoDB URI, which we're going to call joy.string.required on, which means that the application must have this environment variable or it will fail to start. And we can see this if we go back to the terminal, a new error is being thrown to validate the config MongoDB URI is required. So let's add this by creating a .m file in the root of our backend project. We'll create this .env. So our MongoDB URI is going to be equal to MongoDB : // which represents the protocol. And then we're going to connect to 127.0.0.1, which is the address for localhost. And also, if we look at the logs for our Mongo server, we see it's listening on this address on port 27017. So let's specify that port, and then we can specify the database we want to connect to. In this case, we'll have a new database called Chatter. All right, so now that we're reading in our connection string correctly, I want to create a new folder in our source directory called common, which is where we're going to host all of our common modules and other shared code in our application. So in this folder, I'll create another one called database. And in the database folder, we'll now create our database.module. So we'll create a new module from NestJS common and export a class called database module. Now this will have an options object where it has a new imports array. And now we're going to call mongoose module and make sure we import mongoose module from NestJS mongoose. We'll call for root async. So for root async is going to take an options object where we can provide a use factory where we can inject services in NestJS. So we'll inject the config service and we'll call it config service. So we're injecting the NestJS config service from NestJS/config, which is going to read in that .m file and allow us to use it. We'll return a MongoDB options object, which has a URI property. And now we can call config service.get and have the MongoDB URI environment variable populated here from the config service. Now finally, we also need to specify the inject property where we actually tell NestJS which services to inject, which is the config service we're using as a parameter and use factory here. So now if we go into our app module and try importing the new database module. So after importing the database module, if we go back to our application logs, you can see the mongoose module has initialized and our app starts up. And if we look at the logs for the Mongo server, we can see that it's received a new connection and metadata specifying the name of the driver is Node.js Mongoose, which is our Node application. So now that our application is connecting to our MongoDB database, we're ready to start setting up our GraphQL server, which will allow us to create new users as well as querying them. So in the terminal, we're going to need to install a number of dependencies to support GraphQL in NestJS. So I've gone ahead and pasted them in here. npm install NestJS, GraphQL, Apollo, Apollo server, and GraphQL itself. After restarting our server, we can go back to our app.module, and now we're ready to instantiate the GraphQL module. So go ahead and import the GraphQL module from NestJS GraphQL and call for root on it. We can provide the Apollo driver config as type information, and then we need to provide an options object where we specify the driver of type Apollo driver from NestJS/Apollo. And then to tell the Apollo driver to automatically generate our GraphQL schema in memory, we're going to set a new property called AutoSchemaFile and set this to true so that this occurs. So in our server, we'll get an error about no root query type being provided. That's because we haven't actually set up any types yet. So let's get started with a new user type. So we're going to use the Nest CLI to generate a new resource called users. To create the boilerplate files, we need to support CRUD data entry. So we'll call nest generate resource users. And for the transport layer, we're going to use the GraphQL code first approach. We're then specify yes that we want to generate CRUD entry points. And you can see it's created a bunch of files for us as well as updating our app.module. So we can see we now have a users module coming from a new users folder. So let's walk through these files one by one. We have a new users module where we're providing the new users resolver and the new users service. So let's head into users resolver, as this is where all of our interaction with our GraphQL server is happening. And we'll start from the top. So we're decorating this class with an @resolver, which tells NestJS that this is a resolver that's going to resolve a given type in GraphQL. So we're returning a user type here. And if we follow this user type, we can see it's a new user.entity in the entities folder. So we're exporting a user class that has the object type decorator, which is important because this will tell GraphQL that this is part of our schema and is a dedicated type. All of the fields within this have the @field decorator to tell GraphQL about this scalar type. And we can even define more information about it, including the actual integer type and a description. Back in the users resolver, you can see we have our user service being injected. The user service is very simple right now. It's just a CRUD service that is returning stub data, in this case just a string. So we're going to be filling this out later. We have different routes to create a user, find all users, find one, update one, and remove a user. So the create user route is decorated with @mutation because it's a mutation and it acts on the user type as we're specifying here. And it takes in a create user input. So we're extracting the args from the args decorator from NestJS GraphQL, where we specify the name of it and then the type. So if we follow through in the create user input, we see it's very similar to the user entity we just saw, except it has an input type. And it still has an @field decorator for all of its fields. Similarly, for a query, we can see we have the @query decorator, and we're saying here that we're returning an array of users. And we can even specify a custom name for the query. By default, it's going to use the name of the function, but if we want to override that, in this case, we don't want to query find all, we want to query users. So we can change the name of the query like we do here. So the rest of our routes are set up the same way. We have an update user input, which extends our create user input and is used to update the user. So we can really see how the Nest CLI saves us a lot of time in generating all of this boilerplate to generate a new entity. In our browser, if we navigate to localhost 3000/GraphQL, we can see our GraphQL playground is running, which is going to allow us to interact with our GraphQL server directly. And over on the right side, if we take a look at the auto-generated schema, we can see the new user type that was generated, as well as the new queries we have for the users, as well as the mutations to update, create, and remove a user. We can also click on the Docs tab to get a more readable version of each of these new types. So we can write a query by writing query, open object, and query for all of our users, and query the one example field on these users. If we execute this, we can see we get an error because we're just returning stub data right now. So we need to go ahead and update our user service. So let's update our user service to use a new users repository, which will persist data to the database.